Starting this video with some notes, and the first thing I have here is just a table summarizing the different words that can be used for the x value and the y value. These are the domain and range that we had at the very beginning of lecture today. But I realized if you're having to watch these lectures from home because you can't be in class, you may have missed the summary table. Then the second thing is the really key thing, and we'll use this in the problems as we finish out the content for the week, and that is that idea of average rate of change. This is the same idea as slope. And so the formula here is the change in y over the change in x. We understand the change is gotten by subtracting, so you may remember this formula is y2 minus y1 over x2 minus x1. And the little subscripts here mean that you have to use the values in the same order. So your second y value, subtract out the first, second x value, subtract out the first. So we're going to put all that into practice by doing the very last example of the next problem. So the first majority of this problem is done in a separate video. And the only one that's not in that video is this last question, which is to estimate the milligrams of Rocephin in the child at 20 hours. So in order to do that, what we're going to first have to do is we're going to have to figure out what would be the best rate of change to use. When we were looking from up here in this part, the middle part of the problem, the rate of change between 0 and 2.3 hours and the rate of change between 2.3 and 4.6 hours were not equal. So we know the rate of change is indeed changing. So when we want to figure out for 20 hours, which is predicting into the future, we want to use the rate of change that is closest to that data point. And so we're going to find the rate of change. So we want to use the closest rate of change. And in order to find the rate of change, we have to have how the Rocephin is changing for two different points in time. So I have two different points in time here and the Rocephin levels here. So I'm going to be using these ordered pairs. Now, in all of sets of data, the x always comes first, so these two are my x values and these two are my y values, and it might be helpful just to really call them out as to what they are. So this is my first x value, x1, second x value, first y value, and second y value for the context of this problem. So to figure out the change, we know that it is the change in y over the change in x. So the change in y would be to be 104.3 subtract 147.5, and the change in y would be, the change in x, that was the change in y, would be my y2 of 16 point, boy I can't talk, my x2 of 16.1 minus the 13.8. So when I do that math, on the top of the fraction, I get negative 43.2. On the bottom of the fraction, I get 2.3. And if I divide that out, I get negative 18.78. And I understand from the labeling, these first ones were labeled in milligrams, the second ones here were hours, that this would be milligrams per hour. So my understanding is that in this section, the milligrams of Rocephin were being eliminated from the child at a rate of 18.78 milligrams per hour. So as the body is going through the metabolism process and the blood's being filtered through the kidneys and things are going through the liver and all of that happens in our body, the body is filtering out 18.78 milligrams per hour on average for this time frame. It may not be consistent at every moment, but on average for that time frame. So I want to predict where the milligram level is going to be at 20 hours. So I'm going to try to count it down. I know that it's decreasing, the body's eliminating thing. So the first thing I want to figure out is how many hours later So how much later? My last reading was at the 16.1 hours. So if I take 20 hours minus the 16.1 hours, I get that it's going to be 3.9 hours later. So now this is the way that my brain worked it through, and there are a number of ways to work it through. But I was like, well, I know that it is dropping by 18.78 milligrams each hour, and I figured out that this is 3.9 hours later. So I multiplied them. So 18.78, a drop of that much, for every hour for 3.9 hours. So I multiplied them together and I got negative 73.242. And so that to me is that total drop. So it dropped a total of 73.242 milligrams over the last 3.9 hours. Well, then I have to, okay, that's how much it dropped. That's not where it's at. That's the drop. So at the 16.1 hour mark, I had a reading of 104.3 milligrams. And then I'm just going to subtract because it's going to drop by 73.242 milligrams. And so I did that subtracting, and that gave me 31.058 milligrams. And so my estimation is that they're going to be at 31.058 milligrams at the 20-hour mark. Now, if I had the actual formula that explained how the Rocephin dropped, I could probably calculate something more precise than this. But I was not given a formula. I was given this table of data. And so when I'm given a table of data, what I can do is I can find the closest rate of change. And so we used from 13.8 to 16.1. That was the time frame closest to what we were looking for. And so I found the rate of change for that time frame. And then I had to ask myself, how much later am I looking for? And so we found that was 3.9 hours. And so we found the total drop of 73.242. And because that's the total drop, not the answer, but how much it's going down, I then took the reading from the 16.1 hours and subtracted out this drop to get what I have as an estimate for where the Rocephin level would be at the 20-hour mark. So I hope that helps you out in how you would approach this type of problem.